Good evening, everyone. This is Dawn. I'll be moderating this event. On behalf of ASQ Innovation Division, I would like to welcome you all to this webinar, and I hope you are all keeping safe and staying healthy. The topic of tonight's webinar is Applying System Engineering V-Model to Enhance Performance Improvement Across Projects and Assets. This webinar provides an overview of how system engineering V-model and implementation of Lean Six Sigma concepts optimization, standardization, and digitization can be applied within the project and asset lifecycle. The learning objectives are high-level overview of system engineering V-model and its applications, selecting the right projects to meet objectives, and some examples of the CI Lean Six Sigma, focus improvements in select, define, execute, and operate phase that can add valuable outcomes, and typical examples applied to execute operate phase of project assets. Please note that this webinar is being recorded, and the recording will be available on ASQ Innovation Division YouTube channel. In addition, there will be 10-minute time after the presentation for questions and answers. Please post your questions on the Q&A panel of the WebEx too. Tonight, our speaker is Mr. Suresh Prabhakaran, talking for us from Down Under. Thank you very much, Suresh, for accepting to be our speaker today. Mr. Suresh Prabhakaran is a mechanical engineer with more than 20 years of extensive experience in quality management, inspection, business, performance improvement across oil and gas, mining, power generation, and has worked with EPC and operators both within Australia and abroad. Suresh has led Six Sigma projects with GE and of late with Shell, and was recognized within GE and Asia for reducing COF cost of failures. He has also represented Shell Australia at Global Conference as part of Quality Achievements and API International Conference. Again, thank you very much, Suresh, for accepting to be our speaker tonight. Without further ado, I would like to hand it over to you. Please take it away.
Thanks, Dawn. Yeah, thank you very much for the opportunity to present at ASQ. It's a pleasure to deliver to the members of ASQ and to get their thoughts and feedback. So as Dawn said, that I am from Down Under in a place called Perth, which is west of Australia. This presentation is about Six Sigma and system engineering applications. There was a huge spike in innovation during the Great Depression. Companies like Microsoft, Facebook, IBM were all born during Depression. They were collectively collaborating on technology, on optimization. They're all billion-dollar companies today. Similarly, technologies will emerge post-COVID. Optimization, digitization, and big data will be the key to performance improvement. Technologies that will get uplift post-COVID. The need for physical distancing will result in a surge of technologies that minimize human contact and automate entire processes. Robotics, industrial and home, big data, automation, 3D printing, remote healthcare, insurance, pharma, remote education, growth in online games, renewable energy, hydrogen, solar, a lot of government funding going into the new projects in terms of hydrogen, solar, renewable, recyclable, energy generation, supply chain disruption. More automation and robotics will drive low cost, cycle time, reducing cycle time and enhancing safety, quality, and reliability elements. When you look at what has happened over the last 4 to 6 months, you can see a lot of changes. You can see robotics, food delivery. You can see scuba diving kit used as ventilators, temperature measurements, robotic applications, and positioning technologies like drone, which have really taken the market by storm. Similarly, spraying disinfectants across communities. has taken a big step in terms of automation. Which industry are you from? Question.
You can post your answers in the Q&A panel as well as the chat panel. So one answer that has been posted is medical. Cement industry.
Excellent. Yeah, so that's really good in terms of medical and cement industry. Yeah. Good to know the diverse background. I'm from oil and gas mining. Yeah.
Sorry, the other answer is education.
Excellent. Yeah, wonderful. So in order to understand the objectives of the session today, we need to understand what are the objectives of a company from a quality management perspective, from an ISO 55000 perspective. What are the objectives? So that will be the first topic. What do we want? What does a company want? And from people, processes, and product approach, how do we look at those three approaches? What is cost of quality? What does it mean? The context of the company objectives. A high-level overview of Lean Six Sigma and system engineering V model and its applications. Selecting the right projects to meet the wider objectives. Continuous improvement opportunities. So what are the opportunities for us in the multiple phases? Yes, you may be in education, you may be in cement industry, you may be building a new cement plant, you may be building a medical industry where you're going to release a new product. The concept and the philosophy is the same. It is developing a new product which is possibly going to treat a COVID. Is going to be a COVID vaccine, or it's going to be a cement industry. You're going to try a new type of cement which is possibly going to make a difference in the marketplace. The focused improvement and define an asset phase. So with some examples. So when you look at the company objectives, so what does a company want? Even when you look at the personal, a lot of this can be applied to your personal life as well, right? So if you look at ISO 55000, ISO 55000 is asset management standard, and the ISO 9001 is our quality management. So when you look at this and look at you're creating a product or a project or an asset, so what are the final outcomes and objectives for us? It's going to be definitely compliance. We want it to comply to the requirements, the standard, and the regulations. Secondly is defect elimination. We don't want defects in it. We want to make sure the cost of failure is less. The safety incident elimination. We want to eliminate any safety incidents. We want to improve financial performance in the cycle time. We want to be delivering projects on time, the maintenance schedule on time, the repair activity, or products specific. If it's education industry, is going to be introducing online learning on time, or it's going to be cement industry, new product, delivering cycle on time. So in terms of customer satisfaction, when you're looking at customer satisfaction, so how do you get that feedback from the customers? It could be online book, education industry, or a cement industry, or a medical industry. Finally, how do you get that feedback and apply those changes as part of the PDCA, as you can call it, and innovation and higher productivity? So how do we apply those elements of innovation? And to make sure that finally the company wants to increase the sales and order, long-term existence in business, and reputation. So these are the major objectives anybody or any company from a personal or professional basis, you'll be looking to accomplish each of these elements, right? Some of them specifically may focus on one or two elements. But I just want to know your feedback on what do you think is important for you. So this survey, the second survey, which objective is the most important that you would like to implement within your company or organization? Please respond by numbers if you have difficulty in writing the full word.
So one answer that has been posted is 1, 6.
Yeah. Excellent. Yeah, that's good. Good to see. Yeah. So the different, people have different drivers as well, depending on which department and which industry it is. Yeah, so it's good to see a varied response here. Yeah, excellent.
Also another 6.
6, yeah, excellent, wonderful. So I'm sure that we are aligned in terms of the objectives, so which is good. So when you look at the proactive approach, so there are 3 different areas we can really apply those changes. One is we can improve the process. So when you're improving the process, it could be, for example, creating an online product in the education sector. It could be in the cement industry, you're creating a product. So it's pretty much a repeatable cycle of cement manufacturing. It could be a medical industry where you're repetitive producing those tablets or the vaccines. So it could be repetitive. It could be a new product as well. It could be a new cement product. It could be a new online delivery item for the education. It could be also from a medical perspective with a new vaccine. It could be a new tablet for the situation we are in right now. So it could be multiple areas. So it could be a new product or an existing product which you are repeating. It's a repeatability. So when you look at the processes, so what can you do in that? You can reduce the cycle time of producing those products, reducing the defects. In terms of people, you can look at competency, coaching, development exercises to empower people. How do we get the people primed up? If you are a leader, or how do we engage in that fashion to produce and meet our objectives, which I just showed you? How do we engage them and create the urge in them to develop and deliver on those objectives? So that is important. Thirdly, is a product. So how do we meet those product expectations? So what are the customer requirements? What are the company requirements? What are the standards? So how do we meet those? So these are the 3 key elements. When you look at any plans or management plans, this will cover mostly these 3 elements. And you can do a risk analysis, like for example, in a product, they do FMEA in a running asset, and then risk assessment in projects. And products as well, you have different options of doing risk analysis to identify what are the predetermined failures and then apply risk mitigations for it. When you look at cost of quality, so cost of quality is 2 types. One is cost of good quality and cost of poor quality. So if you look at the center line, that is where I think how the cost of quality, the items above the center line is all cost of good quality, which is the prevention cost, appraisal cost. So the prevention cost is making sure you have a good QA and QC process in place to catch these defects before going out to the customer, meeting customers. So making sure you have good work instructions, equipment service, QA inspection and test verifications. But the cost of poor quality is around internal failure costs. It could be scraps, reworks, and also the warranty, customer feedbacks, returns, customer complaints, failures, the cost of lost time. Now, in a nutshell, I think ASQ has a Six Sigma division, but I just wanted to give you a nutshell explanation of what is Six Sigma for people who have just joined and are keen to learn a bit more. So Six Sigma is a discipline statistical-based, data-driven approach and a continuous improvement methodology for eliminating defects in products, processes, services. So it is a data-driven approach, Six Sigma. So what does it mean? So when you can see on the extreme right-hand side, you can see 3 different units, right? 3 different units, and basically 3 different components. And out of these 3 components, you have 12. Out of these three units, you have 12 components in each unit. So there are 36 components altogether, and 1 unit is defect in that. So basically, you have to calculate DPMO, defect per million opportunities. That is why Six Sigma looks at million opportunities. And when you do the calculations for defective components, so 1 is defect out of that, out of 36 components. So you have 36 components into this. 12 into 3. Into 1 million will give you 27,777. That is the defect per million opportunities. You take that 27,777 and try and put it into the middle table. When you put it into the DPMO section, the defect per million opportunity, 27,777 will fall between 3 and 4 sigma. which is a process yield of 93 to 95% approximately. Process yield means the product will be good for 95%. So it's the rest of the 5% we want to improve defects. So we want to bring the sigma value to 6 sigma. And that is our goal. If you have to eliminate the defects, the defect count at this point is 27,700. So we want to bring it down to 3 defects, 3.4 defects, which will give us 99.99, and that meets our 6 sigma requirements. So in terms of 6 sigma, it is about a data-driven approach. Is trying to eliminate the defects. So in terms of a defect count, if you have, for example, an education industry, or you know, in a pharmaceutical industry, or you know, the cement industry, you're repeatedly manufacturing products and tablets and online you know, educational equipment. So educational you know, online educational modules. So basically you will definitely look at option to optimize. So if it's a failure in a bigger product than say two are failing, then why don't we eliminate those 2 failures in an online you know, online presentation or whatever it is. So the concept is around the key factors. If you look at any defect elimination team, it is about defining the problem. So what is the definition of the problems? How do we define the problem, taking those problems? So I would urge all of you to go to each of those to the management and ask them what are the top issues in terms of quality, cost, you know, delivery schedule, cycle time, and reliability. So what are the issues for us? So take those problems. If it's the top 3 in each of those, take it and then start working on it, and that way you can really make a difference. So defining those problems are critical, and I think having that link with the management, if you have to make a difference in your workplace, you have to take things, go beyond the existing, say, compliance, right? There are 2 elements to quality. One is sitting in compliance, and then you want to innovate and you want to sit outside the box. Then basically you need to come out of the box and look at, you know, how can I bring value to the organization? How can I be different? If you have to do that, you have to be able to look at things differently. You have to sit outside the square. So then measure the issues. So to quantify the problem, analyze the issue. So what, identify the root cause of the issue. So why are the top 3 issues happening? So ask 5 whys. So there could be RCA, different methods, right? It could be taproot method, it could be fishbone analysis, and then you zoom into the issues, and then you control and then improve the issues. So in terms of lean, there are different options for lean. So when you look at lean, very clearly explained is the different approaches. So one is the waiting time. So are there too many approvals in the system? Is a long wait time or lead time? Is there 100 emails waiting in the inbox, documents to be signed? So waiting is one of the components for lean. So lean practices to maximize value for client by reducing waste. So as you can understand, previously the Six Sigma was about data, whereas lean is about eliminating waste. So how do we eliminate waste in the workplace? So when you look at that, waiting time is one. Secondly, transportation. So how is the flow of materials? So it could be cement, it could be, you know, the medical industry or online equipment. So how is the transportation happening? Is there sufficient? Is there a good flow of the material? Is there something you can do better? So how many transactions are accomplished in a task? And the lack of integration between the processes. Batch processing, also batch processing inventory is also one of the aspects, right? So inventory, having the right inventory for production of the pharmaceutical industry, for cement industry. Do we need to bring raw materials in advance? Are we can we save costs by bringing metals on time? It's going to be a challenge because the supply chain disruption has happened right now because of COVID and multiple locations, and then global regulations changing. So it is going to be a challenge in applying the JIT right now in this scenario, but it's an option for you to create that chain. If it's going to be a local source material, there are options for you to apply those elements of just-in-time technology where the material arrives, you don't keep a lot of spare, and they can reduce cost for a company. And motion analysis, the lack of standard operating procedures, is there a lack of standard operating procedures, and use of emails is overloaded, wasting time looking after forms. So there could be multiple motion analysis, the worker movement between the workplace. So you can go and physically look at motion analysis. If you can sit in one place in a shop and look at the people movement and then dig deep. It takes some time, but it's really worth it if you're planning to go into that level of depth. And then overproduction. So are we producing more than what is required? Are we producing more or too much information? Producing hardware before instructions are arriving. Production of parts of stocks. Overprocessing due to ineffective tooling or design. Treating defects by inspections, repair work. Reworks. Do we have a lot of reworks? Are we rechecking? And underutilization. Are we utilizing the people we have, or are we underutilizing them? Is there a wasted talent? So I think you can dig deep into all of these 8 elements. It's very powerful elements, and I'm sure that if you dig deep, you can do a lot of activities into that space. System engineering. System engineering, what is it? It's an interdisciplinary field of engineering and engineering management that focuses on how to design, integrate, and manage complex systems over the life cycle. So as you can see from the slide, is that the asset owner, he wants to have an asset, and he will give those output requirements. Okay, this asset has to, for example, educational company. So as an owner, you will say that, okay, I want this online module for working for 1 hour. It has to be really descriptive. It has to create the KPIs, what I require from a cement product. Yes, I wanted to meet the expectation for life of a house, so it can stand for 25 years. It has to meet so much capacity in terms of tensile properties and mechanical. So whatever it is. Similarly, the cement industry, the pharmaceutical. So you can create as an owner what do you want as output from the asset, and define those requirements. So at a high level, you define those requirements, and then it goes to the designer. The designer designs meeting your expectations, and then he gives it the plans and specifications from a high level, from a feed. He gives it to the constructor. The constructor, he develops the products in terms of the processes, and then he gives it back. He constructs the whole facility, and he gives it back to the owner, and then it moves into the operate phase. So my next question is around, have you applied system engineering in workplace? Can you please provide an example if you have?
You can type in your answer. So one answer that has been posted, the answer is I think so. We look for the ways a process can break and then try to prevent those failures.
Sure. Yeah, that's good. Okay, that's good. Excellent. Yeah, thanks for that. So when you look at a model, so this is the system engineering B model that is the focus for today, is how do we look at the product, right? So when you look at the extreme left side, you have the select phase. You select the concept selection across, for example, the education sector, the cement industry, or the pharmaceutical industry. You select the concept of a new product. So you decide what is a concept, and that is a concept select. Then it moves into the design phase. When it moves into the design phase, it moves into this. So the concept operations, how do you want to develop this product? What is the concept of operations? At a high level, you decide, okay, what is the whole strategy? Then you come and define systems. Now, when you define systems, basically it is about a high level system. It could be utility plant. It could be a power generation system, which will have 2-3 generators and producing 2 million, 2 megawatt power unit, or with a set of different utility systems. It could be hydraulic power systems. It could be water systems. It could be multiple systems. Right? So at a high level, you define the systems. Then you go down to subsystem. Subsystem means for me, for example, the next level down, it could be a generator. So okay, what does a generator mean? So what are the subsystems below that? So that is a subsystem definition. Then if you go down along the model, then you're going into detailed design, and then you're coming into unit equipment test. It could be equipment, could be a pump or a motor. For example, in the pharmaceutical industry, it could be at a ground level. It could be a cement pump, or a crusher, or it could be for an online. So for an online educational, I'm just thinking about there could be system test, right? It has to meet certain elements of system testing for an IT product. So that is the difference, and how do you meet those expectations and deliver in terms of digitization, and how do you link it up with digitization? So that is the option. So then going up on the VCO on the right hand side, then they design it. So design is a very crucial phase where you have the system, subsystem, and the equipment. Then you implement it, and this is where the constructor comes in and he installs the product. It could be a hardware, it could be a software, it could be hardware solutions for an educational industry, it could be a unit or a system, subsystem level equipment installation and testing activities for a cement industry. And also it could be for the pharmaceutical industry, testing equipments at a high level, product and system, subsystem level. How do we make sure that it's all good? So definitely the concept is applicable across any type of industry. And then on the right hand side, you move into execute phase. After doing execute phase, then you test each of them. You test the equipment at the ground level. This is called unit testing on the right hand side. Then subsystem, you test the subsystems to make sure the subsystem verification is good. And then the system verification, and then you do the validation finally on the top right, and you validate whether you have built the system right, whether the whole system wise you're able to get the expected outputs from the system, and you're able to deliver on those expectations. And then you hand it over on the right hand side extreme to the operate phase. And that is the operate phase where operations and maintenance come and they take the asset from the project team, and then they do the changes and upgrade. So if there's any changes or modifications, and they do the brownfield modifications, and that's how the whole cycle is. So when the V model is very powerful across any industry, it can be applied, and typically, it's how we look at it and how we can do a lot of changes in that. So now, when you look at the V model, so the high level was the V model. Now when you look at the concept phase, the concept phase is around systems. You're going to define the requirements. Okay, how is my education product going to meet those requirements? It could be contractual, it could be legal, it could be from a scope of work, it could be engineering aspects, it could be the interface aspects, the system engineering aspects. So how do we design those system requirements, the subsystem requirements, and unit component requirements? It could be a pump. What is that level of pump, right? What is how do we want that to deliver the output so it meets the final system requirements? So these are the requirements coming down the line. Then you do the development, you do the installation, and then you do the verification. So on the left side of the V model, we have all the requirements. Definitions, stakeholder requirements, system requirements, subsystem requirements, unit requirements. And you develop the product, and this is the installation, this is the constructor. And then it moves on the right hand side, it moves into unit component, and then subsystem integration, verification, and final acceptance. When you look at the concept phase and design phase, it's mostly around requirements. Then this is installation where the constructor installs. But on the right hand side, you'll see it's all about verification on the V model. Verification at all levels, and then validation on the top side. So that's how it moves into operations. So what does it mean in terms of system engineering concepts? Right? So if you look at the left side, it's about system requirements. So it's all about defining requirements. So how do we define those requirements? It could be, as I said, contractual requirements, it could be scope of work, it could be legal requirements, it could be regulatory requirements, it could be engineering requirements, it could be multiple requirements, process safety requirements, So there are different requirements. So how do we? So initially you capture those needs, capture the needs of the stakeholders, and then you define those requirements and use a trade-off between cost, risk, and value. Then you define a solution based on this, and then verify if the solution meets those requirements, and then validate those. The needs are captured. So it really means that you get all the initial requirements. So you don't want, so requirements is a very vague term. You can have a high requirement or a low requirement, right? If you are in nuclear industry, you can have it as very high requirements. They want a very stringent safety requirements. From a cost perspective, they're not worried about it. So the drivers are different. But when you go into, for example, manufacturing table industry or furniture industry, they don't want that. From oil and gas industry is less stringent. From a mining industry is less stringent. Pharmaceuticals are more stringent, but in terms of a different application, in terms of health and hygiene. So there are different drivers across the industry. So when you look at it, so what does it really mean? How are we going to build this whole system? So you're doing a concept select. You're going to select the concept, and then basically then you define systems, and then you define into subsystems. For example, a system 1 or system 2, for example, the power generation unit, utility unit, or the gas generation unit. You divide into a system, and then you define that system, the subsystem, and you do the same model of defining and optimizing those requirements. So how do we do that? And then basically, once this is all done at the system, subsystem level and an equipment level, then you're ready to place the order as part of the procurement phase. So when at this point you're going to procure those materials from different, it could be a pressure vessel, it could be a heat exchanger, it could be a pump, motor, and then you order those materials. And then you do system integration. You make sure that all these are assembled and make sure you integrate it and test it and meets the original requirements. So that is the validation here. Then you hand it over to the operate phase. So when you look at, for example, I just brought another system which is around automobiles, right? So all the parts come in, the system parts, the supplier parts, and then it integrates. So you have the main drivetrain, and the drivetrain is about the the axles and the wheels and the drivetrain. So these parts come into that, and there is a lot of work in terms of optimization, having spares. You can apply a lot of lean and Six Sigma concept in that, and then integrates into body, and then finally into the interiors, which is basically the steering system, and then finally the product is launched, and then you are selling this product. So in this particular system, when you look at it, there are different. There's a product, there's a process flow, and a business. There are 3 elements you can take on the top side. Left-hand side, there is system definition. You can define the system, subsystem, the part, the feature. Now, when you look at it, you can ask these questions from a product at a system level. Does the product work as expected? Is the supply chain efficient? Is it at the right speed? Can we optimize those elements? Does the product meet the cost and profitability targets? Are we in line with meeting that? Or are we producing a product which is more, is very costly? So how do we apply those elements? At the subsystem levels, you can look at it as how efficient the production system is, the work and processes, and labor, how each system can return value, subsystem at a subsystem level. Similarly, at a part level, you can look at these 3 elements in terms of product, process, and business. And the feature, does the feature meet those requirements? Does the process reliability create features? So you can develop a lot of questioning process and try to optimize solutions, but while maintaining the quality and the regulatory requirements and the compliance requirements. This is an example from automobile industry. So looking at the continuous improvement opportunities, so where are these opportunities? So when you look at this, the select phase, so this is the select phase and the design concept phase. So there is the select concept phase, which competitive scoping is fit for purpose scoping, right? So what does fit for purpose scoping means? It really means that we want to define the requirements which are fit for your industry. right? What the regulator requires, what the company requires. I know it's difficult to change, but when you look at the CRP model and the optimization model, which I mentioned before, you can apply a lot of elements into the system engineering concept, defining at the system level, and people have not changed their requirements, company requirements, standards, and regulatory requirements for years. It has been going on for years because possibly nobody has to, because the specifications, for example, if you supply the specification to the company has the requirements, which a competitor will also have requirements, which is a slightly different set, and it goes to the supplier, and supplier has his requirement. So these requirements are increasing. So you have to pretty much understand whether your requirements are fit for purpose. It's something we just need to cross-check and check if it can be increased, it can be reduced, or are there areas where you can optimize. So when you look at most of the companies, they are. This is a company for IOGP. They have standardized it across the oil and gas. For example, for the wells, pipelines, top sites, they have developed some standards. For example, a pump, and they have defined the requirements for oil and gas industry. But it's a very good opportunity for you to get into this IOGP website, and this is called JIP 33, and pick up specifications you want for your industry, and then fine tune it to your industry, right? It could be a pharmaceutical, it could be the cement industry, but a pump or a motor which works in an oil and gas industry, and a pump or motor which works in a cement industry, maybe there's a slight difference. Right? So you take the basic elements and then you look and add certain elements to it in terms of your working conditions and criteria. So applying that DMAC role. So this is the fit for purpose scoping. So that is in the select concept. Next is in the define phase. Now the define phase is very crucial, is because this is the phase where you're going to design the whole project. It could be an asset, right? At the operate phase, once you're already in the operate phase, you can't do a lot of changes. It's very expensive, and especially when the asset is running, it doesn't allow you to make changes because you're already producing financially from that asset. So during the project stage, you have a lot of elements in terms of system definition, subsystem equipment. You can do a lot of improvements, and those improvements are the ones which I strongly feel that the digitization aspect, efficient execution, supply chain transformation can apply there. What does it mean by efficient execution and supply chain transformation optimization? This is where you can bring in a lot of aspects of the digitalization world, and look at your project and say, okay, can drone technology be used with the remote distancing aspect? That's something which we can engage for inspections. Is automatic robotic inspection, is that possible? I know people have a challenge in looking at changing, but it's an opportunity for you to look at existing systems and see if you can apply those elements into it, and then look at, for example, asset management testing. So, for example, the systems which you're designing in terms of the motors, pumps, heat exchangers. So how do we measure? So can we do the digitization aspect by keeping probes and sensing the vibrations, the sound? So how do we manage the continuous improvement and aspect of it through condition monitoring? How can we digitize that? So that is through teamwork, right? During the design phase. The design phase is crucial. At that phase, if you are able to define a system and a subsystem combined with a team of quality of a data analyst and also of an IT person and the engineering, 3-4 people, they can do a lot of things. It's a teamwork because quality is not a specialist in the digital, and the digital is not a specialist in engineering. So it is about teamwork and collaboration, right? It is about collaboration, looking at things differently. How can you do? And this session is more to lay seed on, is to grow that seed on how we can bring innovation. Innovation is not just like taking some digital and putting into one space, but it's about teamwork. It's about collaboration. So this is a very high element that you can really apply a lot of the collaboration into that space, because I strongly believe that the digitization, efficient execution happens during the define phase, and you can look at optimization also in the post-feed. In the execute phase, you can look at suppliers, because in the execute phase you're already ordering the material. So the suppliers come into picture, right? So they started manufacturing the powers, the turbines, the boilers, the pumps, anything. So pretty much in that phase, you're already looking at supplier chain optimization and how can we bring good products that meet the expectations, the life of the cycle of the asset. So it could be 25 years for the cement industry. It could be for the pharmaceutical industry. We want to produce that product in good quality for say 10 years. And then for the education industry, yes, how do we test my product, which meets the wider requirements of the industry, of the of the audience. So that is an opportunity there. Then moving into operate phase. So where can we optimize in operate phase? It is you can bring efficient execution, digitization, and supply chain transformation to the optimization phase. It is in production, right? Maintenance. So what are the top 3 production issues? What are the maintenance issues? And what are the CMMS and workflow, asset management space, the reliability space? Does our product work? So what are the top 3 reliability issues? How can we eliminate that? So how can we introduce digitization and big data into that? How can we bring the ontology, the industrial ontology or the maintenance ontology? Ontology is about bringing big data. But our CMMS systems, and there's a challenge in that space, is because CMMS system has been created so many years back, and people at that time possibly would not have done a proper root cause analysis on what are the failures. So it may be a challenge for you to dig in, but what you can do is start a clean slate from now on and develop that. Okay, how can I bring maintenance, good workflow, good data management, big data into that, creating that ontology and defining those defects. And how can I bring it into support functions, logistics, quality, inspections? So what can I do in that space, working as a team, to bring those value to the maintenance departments, to the reliability operations, so engineering. So firstly, you need to know if you are going to go into that depth, to know, sit with the management, show them the objectives, what I showed you, and then to create the value in terms of top 3 issues they have on each of those areas. It could be maintenance, it could be reliability, operations, and then dig deep into that. And then you can really go into root cause analysis, eliminating those issues. So definitely you can create a value in that space. So that is the areas where I feel collaboration and digitization, data, big data can apply. And how you're able to create that space is a very innovative space right now, because everybody is talking about it. And we talk about quality 4.0. Quality 4.0 is just that. It's just that you take that defined phase and you convert it to create value to the customers in terms of adding data and digitization. So when you look at some of my examples here, so we had a couple of assets, like I was working with GE, and we delivered some of the skids. The skids were delivered to power generation companies, which were generating power. So these are HPS skids, delivers hydraulic power unit. The top 3 issues in that was leaks. Right, we had considerable leaks. Actually, you can see 2 motors into that system. So we had considerable leaks in the module, and then the problem statement in that was to eliminate leaks. So we took that as eliminate leaks, and we had a lot of vibrations. As you can understand, vibrations with 2 motors in a system, you can create a lot of vibrations. And then design from an acoustic perspective, it was sound issues. So we had the regulation requirements of 80 dB, and we were getting more than that. So it was not meeting our requirements. So we tried to reduce these 3. So these were the 3 areas we took projects on: eliminating leaks, eliminating vibrations, and eliminating the noise reduction aspect. So eliminating noise from the equipment. So And we took this as a challenging project and we applied, and we found some of the issues were on leak fittings, competency issues, and of the technician who was doing the tightening. On vibrations, we found issue like correct type frequency designs, the piping design issues, the maintenance issues, alignment between pump and motors. On design side, we found we kept good quality insulations and we reduced the noise level outside the unit. So I think it took 1.5 years, and we took these projects and we analyzed the data of different so many years, and then we found the root cause and we tried to fix it. At the same time, during fixing, after 1 year, we were still finding issues, and it's a process, right? As you find issues, you go on fixing it. So but finally, after 1.5 years, we were able to get that to a certain level, to a Six Sigma. And it's a challenge, is because the leaks tend to happen, but you got to make robust and keep on working on your goal. So I think that was something which I wanted to share with the team. Next was on the drilling side, right? So we worked on a lot of drilling equipments. So the cost of quality in drilling is around 20%, which is approximately, so one well approximately costs $50 million to drill. So you normally don't know the challenges in drilling is because equipments fail, and then that is a lost time cost of failure, and it adds to a lot of unwanted cost to the company. So it is around, for $50 million, you have 20%, which is $12 million is approximate failures for well. But applying good quality systems proactively in terms of process, people, and product, can make a lot of difference in terms of good quality management systems, applying lessons learned, auditing non-conformances, inspections. We were able to reduce, so this is on a Prelude well, we reduced it to 2.4%, which is industry average is 20%. We reduced non-productive time to 2.4%. And then the final well which drilled was 0.7%, better than even that. So definitely carrying that concept of continuous improvement is always, you have a goal, you can make a difference. So when you look at it, so we really saved around $11.9 million the final well, which is quite a big achievement when you consider, we have $12 million. So we really saved $11.9 million with the expense on terms of inspections, maybe around $200,000-$300,000. And this is another product, which is the shaft, right? Shaft which is used, which has got a bearing, and the bearing area normally gets worn out, and the grooves from the seal. So as you can see, the grooves bearing from the seal. So we used high velocity oxy-fuel technique, and we reduced the cycle time for the shaft. So initially we were having the main shaft considerable cycle time changes, and that was impacting our bottom line cost for this particular company. And they did this coating, and then it reduced the breakdown time and considerably enhanced the life of the asset. So that was one factor. So we need to look at things like this, which is maintenance aspects, which could be the top 3 maintenance issues. What are these issues? The top 10 maintenance issues, and look at reliability issues, and go in depth to create solutions to that. So that way you can bring a lot of change into the system. So finally, CI cycle. So what does it mean? CI cycle is about performance management. It's about cross-industry benchmarking, cross-industry practices, and business process improvement. Cycle engineer, prior to initiating a continuous business, ask the question: what services are provided? What assets are being managed? Who is accountable for providing these services and managing the assets? How will service delivery be measured in terms of efficiency and effectiveness? And performance-oriented organizations identify baseline performance. What is your baseline performance? And look at the baseline performance and look at the new performance targets. So what is your performance target? And monitor actual performance. And measured business improvements, business process improvements with inputs from benchmark and best practices with innovative ideas. So what does it really mean in terms of assets? So it is about planning, capital works, operations, maintenance, and upgrades, decommissioning, right? So if you have to create a continuous improvement in an asset or in a project or a product, you have to have a continuous improvement culture mindset. It's a mindset shift. You cannot sit in the existing system and say that, oh, we can't do it because it's going to cost so much. Is it worthy? But having that cultural mindset shift is going to bring a lot of value. So it's about leadership. It's about taking that extra step to make the change. Innovation will happen when you change the culture. When you have a culture which people are really receptive and open to new ideas and suggestions. So introduce business process and redesign, identify and confirm all services are being provided and assets are being managed, and convert enabling technologies. How can you introduce data in that space? How can you introduce a digitization element into that space? Is it something which we can look at? So in terms of the distancing, it's going to be a challenge because all the rigs and everything is going to have safe distancing for some time. So are there elements you can add value in that space to cover those safe distancing and to bring value to your organization? A longer term actions will be around fostering continuous improvement in the organization. So how do we do that from a leadership perspective? So discuss this with your leaders in terms of objectives and what are the areas we can do and take the lead on that. Identify baseline services and improvement targets, initiate industry and infrastructure benchmarking. So these are the areas. So in healthcare services, so in pharmaceutical and healthcare services, you can do a lot of things in terms of processes. Hospitals, physicians, nurses can eliminate unnecessary steps in reducing costs, improve survival rates, attract new contract patients. By conducting post-operative surveys, you can validate that customers' feedback. So this is hospital services, and then we don't have the cement and the education side, but I think the key concepts are very clear. It's the same around the industries. For example, the financial services, the loan applications, the banking institutions, unanswered phone calls, messages. So all this data, if you're able to take, then you can really improve that. In the aerospace industry, it's about maintenance. How can you prioritize? There are a lot of things in aerospace industry. It really works in the system, subsystem, and equipment classifications, that space. And the city departments, it's about the construction permits, operations to work. So finally, recapping today's lessons learned objectives. It was to understand asset management system and quality management and how we can apply it, and that we have discussed. Process, product, and improvement approach. Cost of quality and how does it impact in terms of your cost of quality. Quality is in everything. It's in cost. If you deliver quality, then you reduce the cost elements and you meet the schedule, and you can try to combine these elements. High level overview of Six Sigma and system engineering. Select the right projects to meet the objectives. Continuous improvement opportunities for select, define, and execute phase, and focused improvement in the define and execute phase. And that is my slide. Hopefully all of you have gained a lot of information, and please, I strongly urge you to go and apply, and definitely if you have to make a difference, especially in this COVID scenario, if you have to survive, you have to be different, right? You got to make things different, and if you have to make a difference, you have to create the scene for it. If you have to create a scene, go to your management, show them the objectives, tell them if the management is not buying in, tell them that, yes, I want to work on these problems. Go beyond your existing steps if you have the time and energy and create a big value, make it different. Thank you. Thank you very much for that. If you have any questions, please let me know.
Yes, thank you very much, Suresh, for your presentation. You can post your questions in the Q&A panel of the WebEx tool, and there were some questions that coming in during your presentation, so I'm just going to read them out. So the first question was about the selection of processes to address using V model. What are the most reliable sources of opportunities for improvement?
Yeah, so so on the system engineering, we have different models. So I'm not gone into the detailed modeling side of it. So there are different models. So if you go into, basically, I did the MIT course on system engineering and modeling. So there are different models in the industry which are considered, but I have not gone into the design element of modeling to test that this model is good or that. But there are different models. Maybe you can search that out, and different people use different types of models. Yeah.
Thank you. So the second question is, ASQ Innovation Division has been promoting for 10 years that quality professionals play an important role in both phases of innovation generation, creativity, and execution. Do you see quality professionals being valuable on both the slopes of the V model?
Yeah, so this is something which I've been thinking is because a lot of the quality professionals are more the compliance space, right? So if you have to go into quality 4.0, you got to come out of that compliance and look at coming out of the box. If you have to come out of the box, you have to be having that continuous improvement thinking. You have to spend time outside the box, and as I can see, the quality people are stuck into compliance because they want to meet the regulations, they want to meet this, but at the end of the day, when you look at the objectives are different. If you have to have that continuous improvement mindset, you got to get that quality 4.0. It will bring you, it will broaden your horizon, and that is what even I'm planning to do, is to learn about data management. What is data management? Learn about data business analytics. It is something you can broaden, and this is a wonderful time for you, for everyone to within the quality space to engage in that knowledge. For how do we broaden ourselves to the new technologies, right? Learn about basic Python, or how do you get into the Six Sigma concepts? How can you broaden yourself so you can bring a lot more variety, and rather than sticking into one industry. So you never know, because the life is changing day by day. You never know, tomorrow we may not be in a job or whatever it is. So having that multiple skill set, it gives you a wider opportunity going into the quality 4.0 and innovation. Applying those elements of modeling will give a lot more value to the quality engineers moving forward. So if you have to be in that space, you have to start working now into the digitalization aspects and the big data aspects. Thanks, John.
Thank you. Please post your questions in the Q&A section of the WebEx tool. And I would like to remind everyone that you can find the recording of this webinar event on ASQ Innovation Division YouTube channel. So I guess there isn't any more questions.
Sure. No problem. So I think if there are no questions, I think we have a couple more minutes. So yeah, that's good. It's really good. So I really encourage all of you, including me, that it is a challenge to think about digitalization, because people in the mechanical, the existing space, it is a challenge to change, right? Because we are pretty much fixed to our work and we can't think beyond, and that has been naturally for everybody, right? People don't like change. Change management is crucial. The world around us is changing. Let us be realistic. The supply chain transformation is happening. Yeah, the supply chain disruption is happening. Companies will have the impact. Global impact will be felt. If not today, tomorrow, things will change. But how do you see yourself, being a wider contributor? It's a point to think how you can bring value in the digital space. It's about expanding your knowledge. It's broadening your knowledge set to meet the wider requirements of the society. Tomorrow, you never know what is going to happen. So it doesn't harm to spend some time to learn new things and innovate and to get ahead of the technology. So you can definitely be a proactive person in that space. Is my strong urge. Hopefully, you'll take it positively and really keep working, and that's the way we need to be as quality professionals.
Thank you very much again, Suresh. And if there isn't any more questions, I guess we can conclude this webinar event. Thank you, everyone. Yeah, thank you all for joining this webinar, and have a good evening.
Thanks.
Have a good day, Suresh. Thank you.
Thank you. Thank you. Bye.